You've seen it 100 times, perhaps more. The familiar scene in movies, TV shows, or even real life. The interrogation room. A cop on one side, a suspect on the other. That large one-way mirror on the wall. The one that lets detectives watch without being seen. It's in every crime drama, police show, and spy flick. You know exactly how it works, right? One side can see through, while the other side gets a reflection. Simple, right? But have you really thought about it? What exactly is happening when you look at that glass? You're saying it allows light to pass through from one side, but reflects it from the other. Light goes one way, but not the other. Does that sound right to you? Doesn't that sound like something glass shouldn't be able to do? Light doesn't care about direction. You flip a light switch and light fills the room. It bounces off walls, passes through windows, reflects off mirrors. It's all the same to light. It doesn't decide what to do. So, how can a single piece of glass decide to let light pass through on one side and reflect it back on the other? Think about a regular window. Light hits it. It passes through. Simple. Now, think about a regular mirror. Light hits it. It reflects. Easy, right? But the one-way mirror does both. How? How can a single piece of glass be both a window and a mirror simultaneously? You might be thinking, it's a partial reflection sort of deal, but that doesn't explain anything. That's just a description, not an explanation. I'm asking you to understand why that glass behaves the way it does. What is the mechanism at play? What property of that material allows it to do this? How does a surface manage to split light into two different behaviors at once? Most people don't ask this question. They just accept the one-way mirror for what it is. It works, so it must make sense, right? But the truth is, once you actually think about it, everything you've been told about how this works is wrong. It's not a special kind of glass. It's not some magical material. The science behind it is far stranger than you could have imagined. Let's break it down. You have a mirror. Light hits it, and all of it reflects. That's how mirrors work. Then you have a window. Light hits it, and most of it passes through. That's how windows work. Now, think about a one-way mirror. Light hits it, and part of it passes through. Some of it reflects. How can it do both? How can the same piece of glass allow light to go one way but not the other? The answer isn't some trick of the glass. It's about light itself and how it interacts with matter. But more importantly, it's about how your brain interprets those interactions. And that's the real trick. Now let's start with the basics. What is light really? Most people think they know the answer. Light is something that comes from bulbs, bounces off surfaces, and enters your eyes. It's how we see the world. But is that all it is? When light travels from a lamp to your eyes, what's actually happening? You can say light is a wave, or that it's a particle, a photon. Both of those are technically correct, but they miss the deeper, more profound truth about what light actually is. You see, light is a form of electromagnetic radiation. Yes, electromagnetic radiation. The same thing that powers your TV, lets you use your phone, and makes Wi-Fi possible. It's not just some mysterious thing that floats around. It's actually the very same force that holds atoms together. It's the force that makes chemistry happen, that gives you the feeling of solidity when you touch something. Light is part of the electromagnetic spectrum, and it operates through the same forces that make your body function. But here's the kicker. Light isn't just a thing that travels through space like a ball zipping across the room. Light is actually the electromagnetic field itself, oscillating or waving through space. Picture a ripple on the surface of water. The ripple moves outward, but the water itself doesn't travel. Instead, the energy is transferred through the field. This is what light is. It's the oscillation of the electromagnetic field, traveling outward at a mind-boggling 299,792,458 meters per second. That's the speed of light. So, when we're talking about light, what we're really discussing is this field of electromagnetic energy vibrating through space, and when light interacts with matter, like, say, glass, the physics gets really interesting. Light doesn't just hit glass like a tennis ball hitting a wall. No, light doesn't behave like that. Instead, it's all about the oscillating electromagnetic field of the light wave and how it interacts with the electrons in the glass. Here's where things get weird. Light interacts with matter by pushing the electrons in the glass. Electrons, as you might know, are charged particles, and these particles respond to electromagnetic forces. So, when light reaches the glass, its oscillating electric field makes the electrons in the glass start to move. They oscillate, jiggle, or vibrate back and forth in response to the incoming light. But here's the thing. When electrons move, they don't just move in silence. They create their own electromagnetic disturbances. They start emitting their own light. Yes, the very electrons that get jostled by the incoming light wave also emit their own electromagnetic radiation. Some of this re-emitted light goes forward into the glass, passing through and out the other side. That's transmission. It's what makes glass transparent. But, and this is key, some of that re-emitted light also travels backward, the same way it came. This is reflection. So, the same electrons that are moving in response to the incoming light are responsible for both transmitting light through the glass and reflecting it back. The same process, two different results. And this is how glass is both a mirror and a window at the same time. The reflection and transmission are happening simultaneously, but the glass doesn't choose which one to do. It just reacts to the light that's hitting it, and the light is divided between going forward and going backward. Now, this is where the concept of the one-way mirror gets interesting. A one-way mirror isn't a special kind of glass with some hidden magical property. It's a normal piece of glass that's been set up to take advantage of light's interaction with matter. But it's also a perceptual trick. The glass isn't doing anything magical. Your brain, however, is. In a typical one-way mirror setup, there's a significant difference in the lighting on either side of the glass. One side is brightly lit, the side you're on, let's say. The other side, the side the suspect is on, is much darker. When the light from the brighter side hits the glass, a lot of it reflects back, and very little light from the darker side passes through. So, from your perspective, the glass behaves like a mirror, reflecting most of the light. Now, on the darker side of the glass, the situation is reversed. The dark room has almost no light to reflect, but the bright interrogation room on the other side is pouring photons onto the glass. Some of these photons pass through to the person standing in the dark room, and now, to their eyes, the glass behaves more like a window. So what's really happening? Both sides of the glass are experiencing the same interaction with light. The only difference is the strength of the light on each side. The person in the well-lit room sees a reflection because there's more light being reflected than transmitted. The person in the dark room sees through the glass because the light from the brighter room is transmitted through to them, and there's less reflection. In other words, your perception of what's happening with the one-way mirror is determined by which side has the stronger light signal. Your brain, as it always does, simply interprets the strongest signal. So when you're standing in the brighter room, you see the reflection. But if you were to walk around to the darker side, you'd see a window. Same glass, same physical properties. But your brain is fooled into constructing two completely different experiences from the exact same reality. Now let's step back and ask what this tells us about how we see, and more importantly, how we experience the world around us. Because this whole scenario with the one-way mirror isn't just about some trick with light and glass. It's a profound insight into how your brain creates your experience of reality. You think you see the world as it truly is. You believe your eyes are windows to the truth, but they're not. They're more like sensors that pick up tiny pieces of the truth and then build a story based on those fragments. When you look at the world, you're not seeing everything in front of you. What you're seeing is a small portion of the electromagnetic radiation that's reaching your eyes. And from that small portion, your brain constructs a whole story. It makes assumptions, fills in the gaps, and puts together a coherent picture. It's a useful shortcut for navigating the world, but it's not an accurate, full representation of reality. And as we've seen with the one-way mirror, your brain can be fooled by something as simple as the brightness of light on either side of a piece of glass. The mirror shows us a key truth about perception. It's not a passive reception of the outside world. It's an active, dynamic construction. Your brain doesn't just sit back and record what's happening around you. It processes, interprets, and distorts that information. It cuts corners. It's incredibly good at it, but it also means that what you're perceiving isn't always a direct reflection of the world around you. It's a model, a simulation that's constructed inside your mind based on the information your eyes gather. Think about this. Two people standing in front of the same glass at the same moment can experience completely different things. One sees a mirror, while the other sees a window, and each person will be absolutely convinced they're seeing the truth. They'll even argue about it, but neither of them is completely right. What they're seeing isn't the glass itself. They're seeing their brain's interpretation of the light signal. The glass hasn't changed. The light hasn't changed. What's changed is the way their brains are interpreting the signals. The brain, in each case, is simply choosing to pay attention to the stronger signal, whether that's reflection or transmission, based on the lighting conditions. This realization is unsettling, to say the least. If your brain can be fooled this easily by something as simple as the direction of light, how much else in your experience is being shaped, manipulated, or outright distorted by the brain's shortcuts? If you can't trust your brain's interpretation of something as straightforward as a one-way mirror, what else are you misinterpreting? How many other things in life are you seeing inaccurately, simply because your brain has decided to pick up only certain pieces of the puzzle and leave out the rest? The implications are massive. You've probably gone through life assuming that when you see something, you're seeing the world as it truly is. You assume that your eyes are windows through which you can observe the world clearly and directly. But the truth is, you're not just seeing the world. You're seeing your brain's version of it. You're seeing a filtered, processed version of reality, and you don't even know it. Your brain has evolved to make quick decisions, to keep you safe, to help you navigate the world effectively. But this doesn't always mean it's providing an accurate representation of reality. The more you dig into this, the more you realize that almost everything you think you know about the world is built on these assumptions. You think you see the glass. You think you understand light, mirrors, and the way they interact. But the one-way mirror is a wake-up call. It shows you that perception is not passive. Your brain isn't just a recorder of light. It's an interpreter, constantly making decisions about what it thinks you should know. And those decisions are shaped by the context, the environment, and your brain's need for efficiency. Let's look at another example. Imagine you're walking down the street, and you see a car approaching. You don't think twice. You just step out of the way because your brain has learned to interpret the shape, size, and movement of the car as a threat. But how much of that decision is based on an accurate perception of the car, and how much is based on your brain's shortcuts? You don't actually see the full spectrum of light that the car emits. Your brain filters out some colors, ignores certain details, and focuses on the parts that are important for survival. You're not seeing the car as it truly is. You're seeing it as your brain has decided it should look. This example demonstrates just how deeply your perception of reality is shaped by your brain's processing of sensory data. It's not about seeing the world exactly as it is. It's about seeing a version of the world that's useful for navigating through life. Your brain has evolved to make quick decisions based on limited information, but this means it's not always seeing things the way they truly are, and you're not aware of it. Now, let's revisit that initial question. Why does this matter? If we can understand that our brains are not passively receiving reality, but actively constructing it, what does that change? Why should you care? The lesson from the one-way mirror is crucial. It's a reminder of the limitations of our perception. It teaches us that what we see is not the whole picture. The world is far stranger than we realize, and we are constantly shaping and interpreting the data our senses receive. So, why does it matter? It matters because this awareness opens the door to a deeper understanding of reality, one that challenges our assumptions about how the world works. Once you recognize that your brain is constructing your experience of the world, you begin to see everything differently. What about those moments when you swear you saw something, but later realize it wasn't quite what you thought? What about the times when your memory deceives you or your perspective shifts, and suddenly the world looks entirely different? Those aren't just quirks of perception. They are built into the way your brain works. The one-way mirror isn't some outlier. It's a microcosm of how perception operates every single day, in every interaction, in everything you think you know. This doesn't mean that your perception is always wrong. Far from it. In fact, your brain is incredibly good at its job. It's constantly making shortcuts, using context, and simplifying the data to help you survive and make decisions quickly. It's efficient. It's designed for speed, not accuracy. But this efficiency comes at a cost. It means you're not always seeing the full picture, not always perceiving the full reality. Understanding this shifts the way you approach not just the small details of life like the one-way mirror, but also the bigger picture, the things that shape your worldview, your beliefs, and your assumptions. It's not about seeing the world as it truly is, but understanding that what you see is filtered and shaped by your brain, by your senses, and by your experiences. It challenges you to question your instincts, your intuitions, and your perceptions, because they are not the ultimate truth. So, what's the next step? The next step is to start questioning your assumptions, to dig deeper into the world around you and to ask, how much of what I think I know is just my brain's version of reality? How many other things in my life am I interpreting based on shortcuts, not facts? How many beliefs, ideas, and perspectives are simply products of my brain making quick judgments rather than true reflections of the world? The one-way mirror serves as a metaphor for everything you think you know. It's a reminder that there's always more beneath the surface, always more to learn, and always more to uncover. The mirror isn't lying to you. It's just showing you one part of a much bigger picture. Your perception, like your brain's interpretation of light, is only one piece of the puzzle. It's a model, a version of reality, not the full, unfiltered truth. And once you begin to peel back the layers of your perception, you start to see the world in a whole new light. The truth isn't always comfortable, but it's always richer, more complex, and infinitely more fascinating than you ever imagined. The world is stranger than it seems, and your brain's version of reality is just one of many interpretations. The key is to be curious, to question, to look beyond what your brain has constructed, and to keep searching for the deeper truth that lies beneath. The one-way mirror isn't just a physical object. It's a tool for understanding perception itself. And once you see how easy it is to be fooled, you'll start questioning everything, every single thing you've ever assumed about how you see the world. You'll start to ask, what else am I getting wrong? What other illusions is my brain creating for me? The answer is unsettling, but it's also liberating. Because the more you question, the more you learn. The more you see, the more you understand. So the next time you encounter a one-way mirror, or any other thing that seems obvious, ask yourself, am I seeing the full picture? Or just the part my brain wants me to see? It might be the start of an entirely new way of understanding the world.